Greetings, class. It's Mr. Caroline here, and today we will be looking at what are called the exponent laws. Now, a few lessons back, you did some introductory work with regards to exponents. So I'm just going to quickly revisit that so you have a greater understanding in terms of how what exponent laws are and what we'll be seeing in today's class. So, going back to what we did in a previous lesson here, dealing with the basics of exponents. Just remember that when you have what's called a power, it actually consists of two parts as we broke this down. So in this example here, we have 3 to the exponent 7, where the 3 was considered the base, the 7 was considered an exponent, and last but not least, those two things combined are what make up what are called power. Now, what the exponent laws will be dealing with is what happens when we take the same bases and when we multiply them and divide them. And you're going to see that once we multiply or divide the same base, something will happen to the exponents. And we're actually going to look at 3 different laws that involve exponents and how we can go through those kind of problems to see how we can solve for them and evaluate them. So this is what I introduced you to a few lessons ago. Now we're going to go beyond that and see some operations dealing with what are called common bases or the same bases. So let's take a look at the exponent laws here. Now, when we're dealing with the exponent laws, again, there are 3 basic laws with an extension to one of them here. So basically, as I keep mentioning in class, that in math, the rules are exactly the same with little twists and turns to make things a little bit difficult here. So you're going to see that in some of the examples that we'll be seeing today. So when we're looking at the exponent laws, the first thing we need to do here is to just take a look at the calculator that you have in front of you. And for some of you that have a different model, okay, just make sure that you know where these keys are. And the first key here is the exponent key. Now, in some calculators, this may be expressed as x exponent y, and in some calculators, you'll have a little hat that looks like this. And again, all those keys there that represent the exponent key will do the exact same thing in terms of how things are evaluated. So for example, if you wanted to evaluate 2 to the exponent 3, all you would have to press is 2, press the exponent key, and then press 3, and then press equals to get the value there, which you would see to be 8. All right, so the exponent laws, in general, there are 3 basic ones, as I said before, with a little twist and turn to one of them. And I'll get to that when we look at that example. And you notice what we have here are the 3 rules, which is the product rule, the quotient rule, and the power of a power rule. Now, what we're going to do here is we're going to break down all 3 rules so you understand what the template or the model presented to you is. So the first rule that we're going to look at is what's called the product rule. And basically what you have here is when you have the same base, what you would have to do there is add the exponents, and if you need to, evaluate it using your calculator. Okay, the second rule we're going to look at here is what's called the quotient rule, which involves the division of like bases. And when you divide the like bases, then you have to subtract the exponents and again evaluate it if you have to. And last but not least is the power of a power rule, is when you have a power inside of a set of brackets and you have another exponent on the outside of it, what you have to do there is multiply the exponent. So we're going to see various examples of these 3 rules so you have a greater understanding of how these rules work. All right, so let's get this started here. So the first rule we're going to look at here is the product rule. Now what we're going to do here again is to use these rules and use the model that you see in the top right hand corner there, so you have a better understanding of how this applies to this. All right, so step number 1 here, what we have here is 3 to the exponent 4 times 3 to the exponent 5. Now you notice that what you have in this question here are 2 common bases, which in this case here is a common base of 3. So what we're going to do here is we're going to add the 4 and the 5 together. And then when we do that, that'll give us 4 plus 5. Now you notice in the first set of instructions here, it says for each of the following, write each product as a single power. So that would be the first step. And the second step is to evaluate. So what you have here, 3 to the exponent 9, that is what happens when you're asked to express something as a single power. Now after we do that, we evaluate it simply by pressing 3, pressing the exponent key and 9, and that's going to give us a value here of 19,683. Okay, so those are just the two main steps, those last two steps there, and that's basically it when it comes to the product rule. Now I put a star beside B here because if you take a look at the middle 5, notice that there's no exponent there. Now when you see a base and there's no exponent, there is an exponent that is invisible there, and that's the exponent 1. Okay, so that's just a friendly reminder that that 5 really has exponent 1 attached to it. So when you do that, I'm just going to rewrite this here with a single base. So what I have here is 5, okay, and raised with the exponent 1 there, now thrown in, I have 3 plus 1 plus 2. So from there, we're just going to add those exponents together, and that'll give me 5 to the exponent 6. And when you evaluate that in your calculator, you will get an answer there of 15,625. All right, let's take a look at another one here. Now, these ones here, just to show you just two different examples, one with a negative integer and one with fractions here, but the rules remain the same. Now, for this one over here, what we have here is negative 2 to the exponent 3 in brackets, and negative 2 raised to the exponent 2 also in brackets. Now, I want you just to be careful of the form here because I want you to see that the negative 2, okay, inside the brackets must be written as a negative 2 inside the brackets when we express it as a single power. So what we're going to do here with the 3 and the 2 is add those exponents as you see. So as a single power, what we have here is negative 2 in brackets raised to the exponent 5. Now, when we're dealing with exponents in general, back in the previous example, remember I mentioned briefly that when you have a negative integer inside of the brackets, depending on what the value is for the exponent, okay, if you have an even number, when you have a negative integer inside the brackets and you have an even number as the exponent, what you'll have there is a positive answer in the end. In this case here, you notice that my exponent here is an odd number. So when I have a negative integer inside a bracket and I have an odd number as an exponent, my final answer here will be negative. In this case here, it's going to be negative 32. Now this next one over here, we have 1 over 2 in brackets, raised to exponent 2 times 1 over 2 raised to exponent 4. Again, we're just adding the exponents accordingly. Now from here, again, when you're looking at the base that's inside the brackets, we have 1 over 2 raised to the exponent 6. Okay, so a couple ways you can do this. You can either raise both the numerator and the denominator to exponent 6. Okay, or you can actually evaluate this in your calculator in one shot. So I did introduce the fraction key in your calculator there. So if you input it inside the brackets, 1 fraction key 2, close the brackets, and you raise the exponent 6, your calculator will automatically give you an answer there of 1 over 64. Okay, so those are just some basic examples with regards to the product rule. Again, key thing, if you look back at the 4 examples we've seen so far, all the steps are exactly the same. Okay, when you're multiplying the like bases, all you do is add the exponents and then evaluate it if required. All right, so next thing here is what we call the quotient rule, and the quotient rule again is kind of the opposite of the previous rule we looked at. Is that when you're dividing the like bases, what we're going to do here is subtract the exponents, and if required, evaluate it. Okay, so what we're going to do here is to take a look at the first question. So you notice that what we have here is a common base here of 9. So what we're going to do here in the next step here is to subtract the 4 from the 6. So in the next line here, we have 6 minus 4, okay, which gives me 9 squared. And then when we evaluate that, that'll give us an answer here of 81. Again, going back to the question here, this 9 to the exponent 2, that's what it means to express something as a single power. And then to evaluate it is simply just to put it in your calculator. Now for part B, notice that this 4 over here has a missing exponent. Okay, it's actually invisible. And anytime, again, when you have a base with no exponent, there's really an exponent 1 there. So I'm just going to rewrite this now with that exponent 1. So we have a common base of 4. And what I'll have here as an exponent is 5 minus 2 minus 1. Then from there, that will simplify to 4 squared. And that will give me 16. Okay, so again, just looking at these two examples, notice the steps are exactly the same. Again, when you're dividing the like bases, okay, all you have to do is to subtract the exponents and evaluate it where required. Okay, so in the next set of examples, just for part C, notice I've rewritten it in a different way. So recall when we're dealing with fractions, anytime you're dealing with fractions, okay, what we're really doing there is division. Okay, so between the numerator and the denominator. Now in this case here, the numerator happens to be the -3 in brackets raised to the exponent 7, and the denominator here is -3 in brackets raised to the exponent 4. So since we are dividing the like bases here, in this case here, -3, again, we're going to subtract the 4 from the 7. So keep in mind what we have here is -3 in brackets, and then 7 minus 4, which gives me 3. And when we evaluate this, we'll get a final answer here of -27. And last but not least here, with the fractions here, we have a common base of 3/4. So we're just gonna subtract the 5 and 3 from each other, which gives me 3/4 in brackets squared. Again, from here, you can do one of two things. You can either raise the numerator by the exponent 2 and the denominator by the exponent 2, okay? Or you can simply just use the fraction key by opening up a set of brackets, pressing 3, fraction key 4, and closing the brackets, and raising it to exponent 2, and it'll automatically give you an answer here of 9/16. All right, so that pretty much summarizes the first two rules here. Again, notice the steps are very, very similar. So for the third rule here, we're now going to look at the power of a power rule. Now, for the most basic examples here, all you have to remember is that anytime you see a power inside of the brackets, which is a combination of a base and an exponent, and you have another exponent on the outside of the brackets, all you have to do there is to multiply the exponents. So if you take a look at example A here, notice I have 2 to the exponent 3, which is the power inside of the brackets, and we have an exponent 4 on the outside of the brackets. So in my next step here, I'm just going to multiply those two numbers together, the two exponents together, the 3 and the 4, and what we have here is 3 times 4, which gives me 12. So again, just like the previous examples, that would be the 2 to the exponent 12 would be an example of a product as a single power. And when you put that in your calculator, what we wind up getting there is 4,096. Now, something a little bit different with part B, notice I have two sets of brackets there. I have the square brackets, which are called nested brackets. And then from there, we have an exponent of 2 on the outside of the round bracket. And you notice there's another exponent 2 on the outside of the square brackets. So for this one over here, again, if you take a look at those two 2's, okay, all we're going to do there is multiply those two 2's together. Now, keep in mind what we have here is a -3 that is inside the brackets. And I can't stress this enough that the -3 inside the brackets is very, very important. So from here, what we have here is -3 in brackets, and then 2 times 2, which gives me 4. Now, going back to the introductory lesson with exponents, I did mention that when you have a negative integer inside of the brackets, and you have an even number on an even exponent on the outside of the brackets, your resulting answer here will be positive. So -3 in brackets raised to the exponent 4 will give me an answer here of positive 81. Okay, so that's just a reminder, again, the importance of brackets, especially when it comes to negative integers. All right, so for this next one here, for part C, we have 3/4 inside of the brackets squared, and outside of the nested brackets, we have another 2, so exactly the same thing. So we're going to take the 2 and multiply the other 2 to it, which gives me 4. And again, from here, you can raise both the numerator and the denominator here to the exponent 4, or if you have the fraction key in your calculator, open up a set of brackets, press 3 fraction key 4, close the brackets, and raise it to the exponent 4, and that will give you a final answer here of 81/256. All right, so these three examples you see on the screen right now, again, are the basic ways we can apply the power of power rule to common bases. So this next one over here for part D, I put a star beside because now this would be the example of the twist of the power of power rule. Now you notice that what we have here inside the brackets is 2a to the exponent 4, and the bracket happens to be on the outside. Now there is an extra step for this one, simply because what we have there is a coefficient or a number that's in front of that a there. Specifically, I am referring to the 2. So when we're dealing with a coefficient, okay, as well as an exponent, we do have to apply the outside exponent, which in this case is 5, to both the exponent of 4 and the coefficient of 2. Now, again, pay very close attention to the form so you can see exactly where the 5 goes here. So notice what we have here is that we have to apply the exponent 5 to the base of 2, as well as multiplying it to the exponent of 4. So step number 1 here, we're going to take this 2, okay, we're going to break it apart from the variable a, and we're going to take that 2 and raise it to the exponent 5. Okay, so that's very important to see that initial step there, because you quite often people forget to do that step. Now, this next step here, we're going to take this 5 and then multiply it to the 4. Okay, and that's going to give me 4 times 5. So in the final step here, we just need to evaluate the 2 to the exponent 5, which gives me 32. And then a 4 times 5, that's going to give me a to the exponent 20. Now, again, just to reemphasize the importance for this one, again, if you take a look at the coefficient of 2, okay, you're raising that coefficient of 2 to the exponent 5, okay, you're not multiplying it. So again, with the exponent laws, you're applying the exponent to the coefficient of 2, okay, and then just like the basic power of a power rule, you're multiplying the 4 to the 5, okay, and that's just the basic one there. Okay, if you take a look at your workbook, there are several examples where you get to apply that. Okay, so use the model from this example there to answer those kind of questions. So that's why I have a star beside that one. All right, so now that we've seen the 3 basic rules, we're now going to see some examples where we're going to combine 2 or more of those exponent laws and rules. So for these examples here, just for quick reference, I have the 3 boxes there on the right-hand side to guide you through the process. Now you're going to see that as we go through these, I've again just put some twists and turns here, because notice for the first two examples, we're now involving variables as part of our expression. Now, start off with example A. So notice what we have for this one here is a to the exponent 5 times a to the exponent 2. So in this question here, the common base here is a. Now, since we are multiplying the common base of a here, what we need to do with exponents here is to add them. So from here, in the next step over here, I'm just going to add the 5 and the 2 together, and that's going to give me a to the exponent 7. Now, when you are using variables, okay, there's nothing else you can do from here, because this is now simplified and you cannot evaluate that. So when you're dealing with the variables, please be very careful that when you're once you use exponent laws, okay, for the most part, that will be the final answer to that. Okay, so for part B, a couple of things I just want to mention here. Not only do we have a variable, but notice we have coefficients in front. Now this is where it starts to get a little bit tricky. So step number 1 here, what we're doing here is we are dividing, because you notice that there's a fraction, so we are dividing the like bases. Now the like bases here, much like the previous example here, is the base of a. So what we have to do for this one is to take the base of a, okay, and take a look at the exponents. So for the exponents, what we're going to do here is subtract them. Now, you're probably asking, what are we going to do with the coefficients in front of the a's there, specifically the 6 and the 2? Well, with the coefficients, which are just basic numbers, we are going to do exactly what I mentioned several seconds ago. We are going to divide them, okay? Because again, ultimately, this is a division question. So what we're going to do here is we're going to evaluate the coefficients by dividing. So what I mean by that is that we're going to take the 6 and the 2 and just simply divide them. So 6 divided by 2, that's going to give me 3. And then 7 minus 2, that's going to give me 5 there. So just to break this part down, 6 divided by 2 is 3. And we're going to subtract the exponents, 7 minus 2. So the final answer here will be 3a to the exponent 5. And again, just like the previous example that we looked at for example A, okay, anything involving a variable, okay, there is nothing further you can do with that. Okay, so that will be the final answer to that. Okay, so let's take a look at more examples over here. Again, you can see now that we are gradually increasing the difficulty of these questions. So for part C, what we have here are actually 2 bases, specifically the letter A or variable A and the variable B. Now, when you're using the exponent laws and you have 2 different variables, what you want to do here is to break the two variables apart. Okay, specifically what we're going to look here is we're going to take a look at the A's and the B's separately. So first step over here, let's take a look at the A's. If you look specifically at the A's here, what we're going to do here is, again, first of all, we are multiplying. So if you look at the rules that we have on the right-hand side, then when we're multiplying like bases, we're adding the exponents. Now, again, pay attention to how this is set up, because you're going to see that if you have two different variables, they are completely separate from each other. So if you take a look at the A separately, we have a to the exponent 4 and a to the exponent 2, and I've highlighted these in pink just to show you what exponents we have to add together. So for the a's and just the a's only, we're going to add those two exponents, which specifically the 4 and the 2 here. Okay, so that's just for the a's. We've taken care of the a's. Now we take care of the b's. So notice for the b's here, we have b to the exponent 3 and b to the exponent 5. So we're going to add the 3 and the 5 together strictly just for the b's. Okay, so these, even though the a's and the b's are beside each other, they are completely independent or separate from each other. So for a, we're going to add those two exponents together. So that's 4 plus 2, which is 6. And then b, we have 3 and 5 for the exponents, which gives us 8. So for the final answer here, what we'll have here will be just a6, a to the exponent 6, b to the exponent 8. Again, that's all you have to do for that. When you're dealing with the exponent laws, you never add the exponents of different variables. There will be a time for us to do that, but for the exponent laws, that's not the case. All right, for part D, notice that what we have here, again, is a fraction. So what we're going to do for this one here, since we have a fraction, we're actually going to look at the numerator and the denominator separately and figure out what we need to do. So if you take a look at the bottom, we have 10a to the exponent 4. So there's nothing that we need to do for the bottom. However, for the top part, we do need to simplify that further before we go through the rest of the problem here. Now, in this problem over here, you're going to see that we will be applying 2 out of the 3 rules that you see on the right-hand side there. Now, focusing on the numerator, what we're doing there is we're multiplying those 2 brackets together. Now, anytime you're dealing with a variable and exponent laws, you always want to look at the exponents, because the exponent laws in this case will only be applied to the 2 variables with exponents attached to it. So you're probably wondering, well, what are we going to do with the 5 and the 4? As I mentioned earlier, we are multiplying. So for the coefficients, or the numbers that are in front of the a there, we're going to multiply those 2 together. Okay, so that's the first step, because again, ultimately what we are doing for the numerator is multiplying. Now for the variables, the variables a over here, we're going to use the product rule and add the exponents together. Okay, so notice what I've done there in the next step. 5 times 4, because we're multiplying. Okay, however, the exponents, you're adding them because this is the product rule. So what we're really doing here is we're multiplying the common base here, which is the a, and then adding the exponents attached to the a's. So what we wind up getting here will be 20a to the exponent 5, and then 10a to the exponent 4 in the denominator. Okay, so in this case over here, we've dealt with the product rule. So the second rule, now we need to see what we have remaining, and you notice that we have a fraction here. So anytime we have a fraction, don't forget the basic operation of division is actually happening. So in this case here, since we are dividing, okay, the first thing we need to look at first are the coefficients, which are the numbers in front of the a, specifically the 20 and the 10. So what we have to do with the coefficients, again, since it is dividing, is simply just divide the coefficients together. Okay, so that's the first step. And since we're dividing, okay, specifically dividing the common base here of a, what we're going to do here is to subtract the exponents. So in the next step here, we're going to divide the 20 and the 10 together, which gives me 2. And then the 5 for the exponents, we have 5 minus 4. So the final answer to this will be 2a to the exponent 1, or simply just written down as 2a. Okay, so notice again for that one there, we used 2 different rules to come up with the answer for this one. So for the grand finale, we now have a combination of all the examples we've seen so far. So we have the two brackets beside each other, which we have to multiply. I've also thrown in two sets of variables. So there's a lot of stuff that we have to do first before we actually come up with the final answer. So just to go back to the previous example, where the approach is exactly the same. So if you take a look at the numerator, we need to take care of that first, and then deal with the 2a to the exponent 7 and b to the exponent 5 later on. Okay, so and I want you to see here is that when we're dealing with multiplication, always take care of the coefficients first. So if you take a look at the 4 and the 6 over here, okay, since this is multiplication, okay, the 4 and the 6, we have to multiply those two together. Okay, so that's the first thing we need to worry about. Now, remember that when we have two different variables, we actually have to treat those two different variables separately. So what we're going to do here is we're going to break apart the a and the b, and then add the corresponding exponents of the single variables together. So if you look at the a over here, what we have here is a to the exponent 5 and a to the exponent 4. So we're going to add those two together. And if you take a look at the b, we have b squared. And on the other b there, we have b to the exponent 4. So we're going to add the 2 and the 4 together. And then when we simplify that, 4 times 6 is 24. And then we get a9, b6. Okay, so again, just going back to these ones over here. In this step over here, we have a to the exponent 5 and a to the exponent 4. So we're only adding the exponents of the same variable. Okay, so as I mentioned earlier, the a and the b are completely separate from each other. And from there, in this step over here, notice that we have 24 a to the exponent 9 and b to the exponent 6 all over 2a to the exponent 7 and b to the exponent 5. Now, we have a fraction here, so what we want to do here is to divide. Now, the only thing that we actually have to divide are the coefficients, which are the 24 and the 2. And remember that when we're dividing the like bases here, again, we're treating them separately. So we're going to subtract the exponents of the individual variables. So to start off with the coefficients, 24 divided by 2 will give me 12. And what we're going to do here, we're now going to subtract for the letter A, then the 7 from the 9. Okay, and for the letter B, we're going to subtract the 5 from the 6. So notice in my next example, we have the 12, which is 24 divided by 2. Okay, we have 9 minus 7 because those are the exponents attached to the A. And this one here is 6 minus 5 because those are the exponents attached to the B. So for the last final answer here, the final answer for this will be 12a squared b to the exponent 1, or simply just 12a squared and b on its own. Now remember that anytime you're dealing with variables and you get to this step over here, this is the final step. There's no need to evaluate it simply because you are unable to. All right, so that wraps up the exponent laws. So if you turn to your workbook there or the pages from the textbook, okay, you can get practicing on the different rules, and I'll see you in the next lesson.